Alright, so in this video we're going to show the rest of practice test 4, section 4, which is question from 34 to 38. So all the questions of section 3 and also question from number 1 of section 4 to number 33 of section 4. We have done those problems in previous video, so please check it out. So let's get into our job and let's solve question 34 onwards. Okay, so for 34 we have minus 4n plus 7 is bigger than negative 12, and minus 4n minus 7 is smaller than negative 12. Okay, alright, so they ask what is one possible value of n. Alright, what is one possible value of n? Okay, so let's solve each equation. So these two equations is a simultaneous system of its equations, so both of them has to be true. So let's solve each of equation at the same time. So the first equation is equivalent with 4n is less than, bigger than minus 12 minus 7, and on the lower equation minus 4n is smaller than minus 12 plus 7, right? Like that. So we can keep deriving from here. So this is minus 4n is bigger than minus 19, because minus 12 minus 7 is minus 19, and for this 4n is minus 4n is less than negative 5. Alright, it's negative 5 because minus 12 plus 7 is negative 5. So you can have that minus 5 less than minus 4n, and this is minus 19, sorry, minus 19 less than minus 4n and less than minus 5. So now you can delete the minus sign on every term, but you have to you have to change the sign of the inequality if you want to get rid of the minus sign of every term. So this is equivalent with, we're gonna get rid of the minus sign of every term, so it should be 5 is less than 19 bigger than 4n and bigger than 5, or it's just 5 less than, okay, so it's just 5 less than 4n less than 19, right? 5 less than 4n less than 19. So this is equivalent with n over 4 less than 5 over 4 less than n less than 19 over 4. So over 4, so which is equivalent with 1.25 less than n less than, this is 4.75. Alright, so one possible value for n, so n could be anything like 2, 3 and 4. Okay, I choose 3 as an example, so let's do 3. Okay, it could be 2, 3 or 4, so I gotta choose 3 here, okay, because it's the middle point. Alright, so basically the answer for this question is just that 1.25, right, less than n and less than 4.75. Okay, that's a 5, that's a 1. Okay, so I'm gonna choose 3. Okay, so number 35, let f(x) be a function defined by this thing. Okay, this equation f m plus 1 is equal to 5 with m bigger than 0. What is value for m? Okay, so first of all, to solve question number 35, we must write down the equation first. So let's write the equation down. So 35. So f of x is equal to x squared minus x minus plus 3. Okay, so they ask for us like what is, okay, so let's first calculate f of m plus 1. Well, okay, so let's calculate f of m plus 1. So f of m plus 1 just mean that you're gonna set everywhere with x, you're gonna replace this with m plus 1. So everywhere you have x, you're gonna replace this with m plus 1. So that is m plus 1 square, because x is replaced by m plus 1 minus m plus 1 plus 3. Okay, and now we're gonna expand this one, we're gonna expand this thing. So that is m square plus 2m plus 1 m square. Okay, I'm gonna keep the square. Okay, plus 2m plus 1, and this is minus m minus 1. Okay, so minus m minus 1 and plus 3. Okay, so keep deriving. So m squared we're going to keep intact. 2m minus m is just m left, right? So 2m minus m. Okay, so plus 1 minus 1 plus 3. So that's only 3 left, right? So we know this is equal to 5. This is equal to 5. Okay, so we can say f of m plus 1 is equal to 5. So therefore the right hand side is equal to 5, right? Or in other words, m squared plus m minus 2, right? Minus 2 is equal to 0, because we're gonna delete 5 from both sides. So this can be factored, right? This polynomial can be factored to let's say you can factor it like this. So m squared, let's say, so it has two solutions. One is 1 and one is minus 2. So minus m plus 2m, that's return m, and minus 2 to be equal to 0. So that means m outside, m minus 2, and plus 2 times m minus 2 is equal to 0. So here we can group out m minus 2 as a common factor. So m minus 2 times m plus 2 is equal to 0. So therefore m is equal to 2, or m is equal to negative 2. Okay, but we know that m is bigger than 0, right? But we know that m is bigger than 0, but m is bigger than 0. So we're gonna take m equal to 2, right? So the value of m is 2, and we're gonna denote here m bigger than 0. Okay, like that. So the answer is 2. Okay. Alright, next exercise 36. Okay, this is about polynomial division. Okay, so when 2x squared minus 5x plus 3 is divided by 2x plus 1, we can find out the result as a polynomial and also a remainder, because they were the fraction part, right? R is a constant, and they asked us to calculate R. Okay, so they asked us what R is. So to do this exercise number 36, so first of all we just have to do the division. 2x squared minus 5x plus 3. So we're gonna have to expand this polynomial in terms of 2x plus 1. So that's gonna be 2x squared plus, plus 2x minus, we borrow 2x, so we have to minus 7x, then minus 7, and then plus 10, so this is still equal to the original polynomial, because here is minus 5x, it is plus 3 here, and 2x squared stay intact. So here we can factor out, we can group it like this, so 2x squared plus 2x, and then I get plus this term minus 7x minus 7 and plus 10, so 2x outside, x plus 2, x plus 1, sorry, so minus 7, x plus 1 again, and plus 10, Actually, I want to factor out 2x plus 1. So there's something wrong in our strategy here. So when I factor out 2x here, I factor out x here, it's gonna be 2x, and it has to be x inside here. So how much do we left here, x here? So here is we have minus 6x, and we have 2x plus 1, so we're gonna factor out 3 here. So 2x plus 1, so minus 6x, and it has to be minus 3 here. Yeah, it's minus 3 here, and here we're gonna plus 6, because 6 minus 3 is 3, so it's gonna return the original 3, so it's plus 6 here. Sorry, there was a miscalculation from my end, so it's 6 here. So this gonna yield us x minus 3 times 2x minus 1. 2x plus 1, sorry. And we plus 6 as a remainder. So now, when you divided this polynomial, for 2x plus 1, this gonna be equal to this last expression here divided for 2x plus 1. So let's reduce this fraction. So so we have fraction here, so we can put it into some two fraction. So first of all, x plus 3 times 2x minus 1 divided by 2x plus 1. 2x plus 1, I could be talking wrong sometime, and 6 over 2x plus 1. So that's gonna yield 2x plus 1 here, they're gonna cancel each other out, so where x minus 3 left, and plus 6 over 2x plus 1. So you can see here, so this is actually r, right? 6 is actually r, right? Because r is a constant, so r is equal to 6, because 6 is here. 6 is here, right? So the tip for doing this type of exercise is that you have to try to factor out the common factor. What is divided? You have to factor out what is the denominator from the polynomial, and then you're gonna find the remainder. After the common terms cancel out, you're gonna have left with a remainder, and the numerator of the remainder is actually r. Alright, so lastly we just have to deal with 78 and 37 and 38. Alright. Okay, so let's check for number 37 and 38. Okay, if a ball is dropped, it continues to bounce off the ground. If it reaches a height of 128 centimeters after its first bounce and a height of 54 centimeters after its fourth bounce, the height is reached after each bounce always some fraction, the same fraction of the height reached after the previous bounce. Okay, so let's think about this 37. So 36 is 6. Okay. (37) The ball bounced off the ground. It continued to bounce off the ground. It reached height of 128 centimeters after its first bounce and a height of 54 centimeters after its fourth bounce. The height reached after each bounce is always the same fraction of the height reached after the previous bounce. So which means h of x plus 1 is just hx times a fraction, right? Just times a over b, right? And a over b has to be less than 1, right? This one has to be less than 1. Okay, so we can have that intuition. So h of x plus 1 is h times just a fraction a over b, with a over b has to be less than 1, right? Note. Okay. Alright, what's next? So okay, so here we can say that, okay, so first of all we have h1, then we have h2, it's just equal to h1 times a over b. Okay, a over b, okay. So now h3 is just equal to h2 times a over b, So, but h2 is already h1 times a over b, so we're gonna put it in, right? h1 times a over b times a over b again. So that is h1 times a over b squared, right? Okay. Now let's keep going. We're gonna calculate h4 gonna be h3 times a over b, right? So that is just h1, but h3 is h1 times a over b squared. So this is h1 times a over b cubed, right? So h4 is h1 times a over b cubed. So and here so but we also know that h1 is equal to 128 centimeter, and we know that h4 is equal to 54 centimeter. So so here, so we know that h4 is h1 times a over b cubed, right? So that's just 128 times a over b cubed. Okay, so they asked us, first of all, they asked us for 37, they asked us for the fifth bounce, okay? they asked us about the fifth bounce. Okay, alright. So asked about the fifth bounce. Alright, so first of all, let's delete this intuition. So but I gotta write it, like small again. So h x plus 1 is equal to here h of x, right, times a over b. Okay, city writing times a over b. And this is smaller than 1. Okay, alright, so 37, what do they ask? They ask what is in height, centimeter, in centimeter the moon reach after its fifth bound. Okay, so first of all, to find out its fifth bound, we have to solve for a over b. Okay, so here we can know that a over b cube to the power of 3 is just equal to 54 over 128, and that's a third, right? That's a half, right? That's a half. So a over b is just a half, or 0.5 to the power of 1/3. Okay, that's the value of a over b is 0.5 to the power of 1/3, and that's of course less than 0. So they ask about the height after the fifth bounce. So height of 5 gonna be equal to height 1. Okay, so it's just equal to height 4 times a over b, right? A over b. So that is just height 4. We know that is 54 times over a over b. A over b is just 0.5 to the power of 1/3. So we can plug it in. So we can find out height 5, right? So we can plug it in and find out height 5, right? So it's 42.85 meter. 42.85 meter. Okay, so that's about 42.85 meter, right? So the answer is 42.85, something like that. I mean centimeter, right? Because we are talking about centimeter here, right? Okay, so let's check. This one is kind of dubious. I don't know if I'm correct. It's 53, right? 33. So 42 by the equation is 128 of r square is equal to, okay, a little bit different here. Okay, maybe I have to rethink about it. Yes. let's calculate this again. I'm gonna see 42.85 is correct. I think my calculation is correct. Okay. Okay, so we're gonna check both way of thinking. It's a little bit different from the answer, but let's see. At which head to the nearest centimeter was the ball drop from initially? So 38. What is at what head initially was the ball drop initially? Okay. So we know that h of x is equal to h of x plus 1 is equal to h of h times a over b, and a over b we have also found out that is equal to 0.5 over 1/3, so 0.5 to the power of 1/3, right? So so we can say that h of 1 is equal to h0 times that constant 0.5 to the power of 1/3. So we can find out well, h0 gonna be equal to h1 divided by, you know, the constant 0.5 to the power of 1/3. So that's gonna be 128 centimeter divided by the ratio. So that's the theoretical approach. We have to check our answer again first in this case. Okay, so I'm sorry, there's a mistake in our calculation. Our way of calculating is actually correct, but our calculation contains some error. So here 54 over 128 is not a half. Sorry, that was not a half at all. So that was actually, you can divide it. Okay, so let's reduce it. 54 over 128, that's gonna be 0.1875. It's kind of a bad number. I'm gonna reduce it, you know, like slowly. So we can divide both things for 2. So that's 27 over 64, and that's just actually 3 over 4 to the power of 3, right? So a over b actually equal to 3 over 4. Okay, sorry, that's a miscalculation. So a over b here is just actually equal to 3 over 4. Okay, so that's important. So so here, okay, so and that's less than 1, so we can figure out this a over b is actually 3 over 4. Okay, that's a miscalculation from my side, sorry. So therefore the answer here is not correct. Okay, this answer here not correct. Okay, let me fix it. So here we have a over b is equal to 3 over 4. So therefore when you calculate h5 is just h4 times a over b. So that's just 54 times 3 over 4. 3 over 4. So that's gonna return so 54 cm times 3 over 4. That is just gonna return how much? Okay, so 54 times 3 over 4, that's just 40.5 centimeter. So the answer is 40.5. Alright, so so that's the answer is 40.5. Okay, and for the last question, Number 38. What is head to the nearest centimeter was the ball initially dropped from? So we're gonna calculate H0. So we calculate H0. So H0 is actually H1 times. So it is actually okay. Let's fix it a little bit. So A over B is actually 3/4. So so it's actually 3/4. Okay, sorry, miscalculation. Okay, note A over B less than 1. Okay, so okay, so now we're gonna fix things a little bit. So at what height to the nearest centimeter was the ball drop initially? So H1 now is gonna be H0 times 3 over 4. Sorry, 3 over 4. So H0 gonna be H1 divided by 3 over 4. 3 over 4. So it's 128 divided by 3 over 4. Okay, sorry. So H0 gonna be equal to 128 centimeter times 4 divided by 3, and that's gonna give you 128 times 4 and divided by 3. It's gonna be 170.666 centimeter. So okay, so what you should write in is 171, right? 171 centimeter, and yeah, there you go. It's 40.5, and it's also 171. Okay. Okay, so let's check all the answer we do today. So 34, we're gonna, okay, so we know that 1.25 less than n less than 4.75. So putting 3 in is reasonable. Okay, all right, and 35 is 1. It's 1. Okay, I make another mistake. 35 is 1. Okay, the equation is correct here. Okay, I am sorry, I'm gonna try to fix it. But there was some error. Yeah, okay, I'm sorry, it's m minus 1 here. Yes, m minus 1 here. So, come on, so many mistakes. M minus 1 here, sorry. Miscalculation, so m is equal to 1 or m is equal to minus 2, but m is bigger than 0, so m is equal to 1. So it has to be 1 here. It's just a yeah, it's a mistake in my calculation here. So m is equal to 1. Yes, come on, I factorized it in the wrong way. Sorry, really, I was mistaken. Very stupid mistake, but yes, m is equal to 1 here. So 35 is 1. Yeah. So 3 is okay, 1 here. Alright. Alright. So 36 is equal to 6. 36 is equal to 6 indeed, right? So it's 6 indeed. 36 is 6. Yeah, so that's correct. Thank God I'm correct on this one. 36 is 6. Okay. Alright. 37 is 40.5, as we just calculated. It's just 40.5, and that's correct. And 38, we're gonna have 171. So that's correct as well. So I think that's the end of this section. It was a mistake. I really apologize for that, but please fix it as I have instructed you to. So thank you very much for listening. Have a good day. So on this 35 part, on this 35, please factor out. We're gonna have m minus 1 as a common factor, m minus 1 as a common factor, not m minus 2. I was probably making a mistake and wasn't careful on that one. So thank you very much for coming today. Have a great day. Yeah.